UTDBrainHealth, and this is a sketch of our building. We're not too far from Love Field, so if you're ever in Dallas, we hope you'll come and see us. We have a beautiful building, and it's full of researchers, full of people who study the brain and do different things with the brain and different kinds of people. We study kids and we study adults, we study old people, we study college-age kids, we study soldiers who are coming back from the war, who have post-traumatic stress disorder. Have you guys heard of that? PTSD. We study football players who have had concussions. So we study all kinds of people. We study kids who've had traumatic brain injuries. They've gotten hit, had their heads hit in a car accident, or they've fallen off their bike and hit their head really hard. We do a lot of studies with just about everybody you can think about. So we look at all kinds of different ways, the brain in different ways. We do things just like you guys just did. We're looking at your brains and your reactions.
You guys.
Yep. And we do things with the computer. We also do, this is an EEG cap. This boy is getting his brain activation read through an EEG cap. Those are the little sensors on the cap. We look at genes and DNA. And we do a lot with the MRI and the fMRI to look at brain at the insides of your head without cracking them open. So who knows about anything about the brain? Who knows what the lobes are? Yes?
Oh, I know it's cranium.
Yes.
It's the brainstem.
Oops. Okay, what's that? Does anybody know? Right in here. It is the cortex. The cortex is kind of the outer layer, but that lobe in particular is called the temporal lobe. Does anybody know what it does? Well, on the left side of your brain, it actually processes language. On the left side, okay? On the right side, it processes a little bit differently. How about that part? What's that? Cerebellum, yes. Medulla oblongata is actually deeper in the brainstem. That's the cerebellum. Now we know the cerebellum, it's hard to say sometimes, helps us with balance. If you're good at sports, your cerebellum is very active. But it helps us with a lot of different things. Sometimes people call it the hind brain, because if you were able to take your cerebellum off, it would look like a little tiny brain, all on its own. It also, we know that it gets active when our memories are active as well. So we don't know everything that the brain does yet. We're still figuring it out. How about that part, the very back of your brain? Yes? Occipital lobe, right, very good. What does the occipital lobe do? Yeah, it's seeing, yes. Yes, your eyes are up here, but there's actually the nerve cells go from all the way up here, all the way back to here. And then it sends those signals to different areas of your brain. How about that part? Cranium is kind of the little thing, the top, yeah. Huh? Yeah, parietal lobe. Wow, yes, that's your parietal lobe. Okay, that helps you with sensing, it helps you with paying attention, it helps you with your memory for details. Whoops, went backwards. How about that part? What, I heard it. Frontal lobes, yes. Who knows what the frontal lobes do? Some memorization, but what else? More important stuff than that.
The area where the congresswoman was injured.
Where?
Bullet passed through the front part of her butt.
Yes, the congresswoman was injured through that part of the brain.
She said it.
What is it? Critical thinking. Yes, higher order thinking skills, your reasoning, your problem solving. And this part of your brain, Dr. Katie will talk to you more about it in a minute, develops for a really, really long time. Some of you guys who are younger, it's just beginning to develop, but you guys are right in the middle of a whole bunch of brain development right now. So your brains are changing all the time. So have you ever noticed how sometimes you feel kind of moody, your parents are embarrassing, you're not happy? All that has to do with your brain development and your changing brains. Yes. So who can tell me what is good for your brain? What's good for your brain? What? What kind of food?
Fish.
Fish. Yeah, seafood's very Very good for your brain.
And said rest.
Rest, absolutely. What else?
Knowledge.
Knowledge.
Yes.
Very good for your brain. Okay. Whoops. So healthy food is really important. Berries are really important. Blueberries are really important. They're really good for your brain. It's not an antioxidant. What about exercise? What about exercise? Is that good for your brain? Yes, it is. It is. What's good for your brain? What about that kind of exercise? No, that's silly exercise. But mental exercise is good.
Brain messenger.
This is the brain messenger. Does anybody know what the brain messenger is called? Yes? It's a nerve cell. What is it?
It's like the central nervous system.
There's some in your spine. Yeah. What is it? Does it look like an ear? A little bit, maybe? It's called a neuron. You guys heard that term? A neuron. Okay? A neuron. And there's a whole bunch of these in your brain. But this is the cell body of the neuron. And this is the axon that sends a signal out to other parts of your brain. And these little fingers here are called dendrites. And they're the ones that get the signal from other neurons. So you have a whole bunch of these guys in your brain. They're working, they're sending signals. Yes?
So, did you say this one?
The dendrite.
Oh, so that sends the message to the axon
Yes, it's a chemical signal that moves down the axon to the dendrites of another cell that looks like that. Okay, and the dendrites pick up the signal from one and then they respond to it. Sometimes they respond by getting active, sometimes they respond by just sitting there. Okay, that's called an inhibitory response. Okay, so whoops, how many do you think you have of these in your brain? Okay, you guys are good. Yes.
What is that?
Yeah. So everybody's brain's a little bit different, but we all have about that many neurons. So they're really packed in there, and there's a whole bunch of them. And they make our whole body work. A lot of people think the heart is the most important part of the body, but do you know what makes the heart go? The brain. Yeah, so if your brain is not working, then the rest of your body's not working. So your brain is the most important part. It's like the CEO of everything you do. It's in charge. Okay? So these are very important parts of your body. Okay, so the building blocks of good brain function, healthy brains, are getting good sleep. As teenagers, you guys need as much sleep, almost as you did when you were toddlers. I bet you don't get it. How many of you guys get 9 hours of sleep?
I lost that like 9th grade.
5 hours.
I get 4 hours.
Good nutrition is very important. Physical activity is important. We actually know from brain science that when you are physically active, when you're running or walking or doing anything that's physical, that you're actually building new neurons. So it's building new brain cells, which is really important for keeping your brain healthy. And we know that it's important for memory and all kinds of functions in your brain. Fun is very important. Having a good time is important. Did you know that? Very important to keeping your brain healthy. Having fun. Also, mental stimulation, like learning or reading. Okay? All right, so Dr. Katie is going to do a little game with you.
Okay, so we're going to do some of that mental stimulation, get your brains going. This is zoom out, so there's going to be a little picture. It's going to start out really small, and it's going to slowly zoom out. And you guys shout out when you think you know what it is, okay? Okay, here we go.
Bear.
Okay, glass.
Stop.
It's a pony.
Earth.
An earth. The whole
Earth, very good. Okay, here's the next one. Broccoli. And this is good for your what? Brain. Very good. Excellent. about brain, because I can't just come over to you and open up your skull and start looking inside. So we have to have ways to be able to study that. And so imaging, brain imaging, like when you go and have an MRI of your brain, that's where you're able to look at pretty pictures of your brain. And that's how we know a lot about brain science or neuroscience. And so these are just two examples of different machines we use. This one's an MRI scanner. It looks like a big donut, doesn't it? No. And so you put your head in here, you lay down, and you go into the big donut, and it can take really pretty pictures of your brain. This one is called a PET scanner. Has anyone ever heard of PET? PET? Yes, excellent. And this is also like a big donut. These are basically really big magnets. And this one is cool because you see this person laying down here? And they're looking up into a monitor. Do you see that? And so they're actually looking at a monitor, someone's showing them pictures of stuff, and they're measuring what part of the brain is active. So in this brain, if I'm going to tell you this is the occipital lobe, and if the occipital lobe is really active, then what function is there? What are they doing? Yeah, good. They're looking at something. They're seeing something. Very good.
So is that like what?
No, it's just we color it up. We color it to see what parts of the brain are more active. So it's kind of like measuring metabolism. So you know when you work out, what happens when you lift weights? What happens to your body? You get sweaty, you get hot, right? Because the muscles are active and they're using oxygen and glucose and all that good stuff that's in your body. Your brain does the same thing. When you're thinking really hard, have you ever worked really hard thinking about something and you feel really tired afterwards? Yeah, it's because your brain uses glucose in it. It's working really hard, just like a muscle. Yeah.
So is it true that
That's not true. You're always using a lot of different parts of your brain. They just may not be all working at the same time all the time. Does that make sense? Yes?
What is the purpose of the PET scan? What are you mainly looking for with that versus the MRI?
From a research standpoint, we can see what parts of the brain are active or are working during different tasks. So if I'm looking at a picture of a tree versus I'm looking at a picture of from my wedding, something that's really emotional, I can see what sort of parts of the brain may be involved in thinking about emotional events, for example. Yes?
So is it, well, like, what parts of the brain that we don't
I don't think there's any parts of the brain that you don't use. It's just that